Hello, my name is Rod Martin, and this is Cebu Island. I'm standing in the center of the Philippines, an archipelago of over 7,000 islands. Humans have lived in these islands for at least 24,000 years. Each of these islands is the result of millions of years of movement, tectonic plates one against another. The Philippine Sea Plate sliding underneath the Sunda Plate. There's a great deal about the Philippines which is similar to the mythical Atlantis. According to the ancient Greek philosopher Plato, Atlantis sank in a day and a night nearly 12,000 years ago. Was Atlantis a real place? We don't know yet. But there is mounting evidence in support of that possibility. Thankfully, there are some critical differences between Atlantis and the Philippines. And that's what this film is about. The ancient Greek philosopher Plato was one of the founders of Western philosophy. He is our source for the Atlantis story. Half a world away, the Philippines are a group of islands created by the movement of the Philippine Sea Plate underneath the Sunda Plate, forming islands in what would otherwise be empty ocean. Part of mountain building comes from the friction between two plates, each made of millions of tons of rock, when the two plates rub against one another. Also, the descending plate heats up as it moves downward into the Earth's mantle. This melts the old crust and gives rise to volcanoes. Today, the Philippines are largely volcanic in origin. Atlantis was created much the same way, over millions of years as the Africa plates moved northward to meet the Eurasia. The Africa plate slid underneath the Eurasia, creating mountains and volcanoes. But first, where was Atlantis? Plato was quite specific. The fabled island, if it existed at all, stood outside the Strait of Gibraltar and faced the territory known in Plato's time as the Phoenician Gadara, modern Cadiz, Spain, the oldest European city on the Atlantic coast. The island was the size of ancient Libya and Asia Minor combined. Because of this size, it likely stretched to the Azores volcanic archipelago. Nearly 200 million years ago, as the ancient supercontinent Pangaea broke up, Africa moved northward to meet Eurasia. As the Africa continent moved, the periphery of the Africa plate slid underneath the Eurasia, creating mountains in the process. Perhaps 50 to 60 million years ago, mountain building got a boost. Something happened along the Africa-Eurasia plate boundary in the Atlantic, causing the Eurasia to choke on the Africa plate. Perhaps as much as 100% of the Africa's northward movement locally was converted into mountain building. Then, when the region of mountainous terrain, a new island, reached its maximum height, Africa was no longer able to move northward at this new island. The result of this impasse set in motion the future demise of Atlantis. But now what happens when one object collides with another, but the collision is not head-on? It's really a matter of simple physics. When the westernmost corner of the Africa plate could no longer move northward, yet the remainder of the Africa plate continued to slide underneath the Eurasia with relative ease, rotation was the result. Today, the current Africa-Eurasia-Euler pole, the axis of rotation of one plate with regard to the other, is situated some 1,100 miles, that's 1,800 kilometers, south of the Azores. And today, the overall pattern of Africa plate movement with regard to the Eurasia is one of rotation. With that rotation, the young island no longer received the full force of support it once had enjoyed during its formative period. In fact, the rotation of the Africa plate around this region started to weaken the island. But the rotation produced one other very important effect. For many of us who've worked in an office, we're all too familiar with the dreaded paper jam, when an impediment clogs up the works in a printer or fax machine. Something like that happened with Atlantis. Let me explain. It's not easy to photograph the interior of a printer in operation, so we'll simulate the path paper takes when the rollers drive it forward. At the point of impediment, paper crumples. This is comparable to the mountain building in Atlantis. Notice how the area of damage grows on either side of the original impediment. A similar thing happened with Atlantis, as the new plate rotation forced old plate underneath the Eurasia adjacent to the area of damage. New damage created new impediment, spreading the damage all the way to Gibraltar. Nearly 6 million years ago, the Strait of Gibraltar became blocked, and for nearly 700,000 years, the Mediterranean was a mile-deep desert. After this, over the next 5 million years, the greatly weakened Atlantis started to break apart and subside. Yet the rotation of the Africa plate was not the only force working against Atlantis. Have you ever paid attention to what happens when you sit on a mattress? Or pay particular attention to what happens when you get up? Notice how the mattress becomes compressed when someone sits on it, and notice how it springs back when the person gets up. Okay, now wait a minute. Did you pay attention to her or the mattress? Let's look at it again. See how the mattress is compressed, and then how it springs back? Nearly half of North America and a great portion of Europe were covered by thick sheets of ice. At some points, the ice was over a mile thick. Billions of tons of ice pushed down on the tectonic plates on either side of the Atlantic. As the ice melted, the continents sprang back in what has been called post-glacial rebound. But just as some things go up, others must go down to compensate. As the continents on either side of the Atlantic enjoyed their rebound, Atlantis in between, perhaps geologically the weakest link, suffered the brunt of the required subsidence to compensate for the massive rebound. So what are the key differences between the Philippines and Atlantis? Well, there are two that count. And they spell the difference between a catastrophe which destroyed a civilization and a peaceful day in paradise. Atlantis suffered a loss of geological support as a result of plate rotation. The Philippines, on the other hand, enjoys continued geological support from direct plate movement. Atlantis had two massive regions of energetic plate rebound on either side, forcing Atlantis to pay for their uplift. The Philippines, on the other hand, is safely distant from the rather small sources of weak plate rebound experienced during our modern global warming period. The Philippines, thankfully, has neither of the key factors in the demise of Atlantis. Here I am, safe and sound in beautiful Cebu, Philippines. This is Rod Martin. Be good to yourself.